geosyncline actually represent to elongated basins. These are narrow, elongated depressions found on the earth crust. These are narrow, elongated basins found on the earth crust. And when they are in active subsidence, they are called basins or tectonic basins. Narrow, elongated depressions found on the earth crust, they are basins or tectonic basins when they are actively subsiding. So they are very important from sedimentological point of view as well as from tectonic point of view. Why? Sedimentological point of view, because these are the sites of huge sediment accumulation or large amount of sediment are accumulated in the geosynclines or tectonic basins. These basins may be adjacent to the continent or away from the continent. If we say this is continent, then towards the marginal region, these basins may be present, or they may also be present within the continent also. They may also be present within the continent also, or away from the marginal region. So if this is continent, the geosyncline may be present at the marginal region or away from the continental margin as well as within the continent. So they are basically or broadly classified into two broad categories. One is orthogeosyncline, another is parageosyncline. Orthogeosyncline and parageosynclines. These orthogeosynclines are elongated in nature. Elongated in nature. These parageosynclines are oval in shape. These are elongated, these are oval. And this orthogeosyncline is further divided into two categories. One is myogeosyncline another is eugeosyncline. Myogeosyncline and eugeosyncline. And this parageosyncline is further divided into several categories. They may be exogeosyncline, jubogeosyncline, and geosyncline. This is one type of classification. Another type of classification which tell about the classification of geosyncline, which has classified the geosyncline into three categories, broad categories. One is monogeosyncline, then polygeosyncline, and mesogeosyncline. So this is depending on the orientation of the axis of the narrow elongated depression, and this is the division based on the location of the depression. So first, when we talk about the myogeosyncline, this is at the marginal region of the continental part, marginal region. So this is devoid of any volcanic eruption. No volcanic eruption or no any kind of volcanic deposit found here, which is very adjacent to continental margin or located at the border of the marginal part. And here we found what? Sandstone, limestone, shale, etc. These are the petrological component present here. Sandstone, it's a sand type of rock. Limestone, calcium carbonate, made up of calcium carbonate. Shale, this is argillaceous material. So these are actually shallow deposits. Shallow deposits means these deposits are found in the shallow water bodies. Shallow water bodies. So being the marginal portion, here water is very shallow in nature or shallow in depth. So here we will get sandstone, limestone and shale type of sedimentary rocks. And no volcanism is associated. And if we talk about eugeosyncline, then it is located away from the continental margin or at some distance from the continental margin. And this is characterized by the deposition of gravet, chert and slate type of rock deposits. Gravet, chert, slate, etc. And this is characteristically contain volcanic products. Volcanic products. Different type of volcanic product. Here there is no volcanic product present. Here different type of volcanic product are present. So this is away from the continental margin and this is at the border region of the continental margin. Then we will go to parageosynclines. Parageosyncline is generally oval in shape and these are found within the continental margin or within the continental area. and there is a exogeosyncline, which is a part of parageosyncline or a type of parageosyncline. These are at the marginal region. But this receive sediment from the adjacent orthogeosyncline. This is the parageosyncline, but located towards the border region, and receive its sediment from the adjacent orthogeosyncline. This is what? Exogeosyncline. And geosyncline. This is characterized by a presence of marginal upliftment. Means a basin having marginal upliftment. It is almost oval. It is not elongated. It is oval and located within the continent region. And that is the marginal upliftment. This is what? Geosyncline. And another geosyncline, that is orthogeosyncline. Orthogeosyncline, which is type of parageosyncline, having no any marginal upliftment. So this is the orthogeosyncline type of parageosyncline. And when we go towards the another three different classes of geosyncline, this classification is mainly based on the orientation of the elongated depression, or axis of the orientation of the elongated depression. Here single axis present, elongated depression having single axis or oriented in one direction. That is example Appalachian mountain region. This is example of monogeosyncline type of geosyncline, or belong to this category. Only one elongated depression. But only geosyncline means what? Having more than one depression with two different axes, and these are parallel to one another. Here is a depression, here is a depression. The axis is parallel to each other. This is also a type of geosyncline. And example is Rockies mountain. Just like Appalachian mountain, this is Rockies mountain. Example of only geosyncline. And the last one is what? Mesogeosyncline. Mesogeosyncline means here the two axes of the elongated depression is not parallel, and the depression is separated by a continent or any continental region. And this is the example of Himalayan mountain range. Himalayan mountain range. So Himalayan mountain range is mesogeosynclinal type of geosyncline or mountain type or mountain range. Basically, geosyncline is very much helpful for the mountain formation process. These are the different types of geosyncline we can find on the earth crust. And if we talk about the mode of formation, basically geosynclines form in three major steps. Three major steps. First is, if we talk about the process of geosyncline formation. First is geosyncline phase. Then tectonic phase. Then third one is orogenic phase. The three process or these three phases are mainly responsible for the formation of geosyncline or this type of elongated or oval depression on the earth crust, which is the store region for accumulation of huge sedimentary sequence or thick sediment deposition or accumulation is done in this elongated or oval shaped depressions on the earth crust. So first, geosyncline phase. Here huge sediments are accumulated in a large elongated marine basin. Large elongated marine basin. Deep basins. And 10,000 to 20,000 meter thickness. This is the geosyncline phase. Means there is the accumulation of a huge sediments in this deep elongated region. Then after accumulation to this depth or this thickness of sediments, there is the downward movement of the basin, which faces the large amount of heat and pressure condition. And this heat and pressure make the material plastic in nature. And when this get become plastic in nature, it starts to be folded or start to be crumpled. And under this compression effect, there is the formation of what? Large foldings, and then followed by the upliftment process, where the role of tectonism is very crucial. Here there is the accumulation only. Here there is the tectonic influence under which the material become plastic in nature, and after becoming plastic it get crumpled under compression force, and after that it get uplifted. Now the depression become an elevated region. This is due to tectonism or tectonic influence. And final one is what? Orogenic phase. Orogenic phase means there is the complete formation of a mountain. Complete formation of a mountain. Now the depressed region turned to be a mountainous region or mountainous area. And this upliftment is followed by the subsequent emplacement of different hot molten material from inside the earth, or that is called what? Magmatic emplacement. Magmatic emplacement. This magmatic emplacement of a variable shape and size, that may be batholith, that may be lapholith, that may be lopholith, or variable igneous shapes, they get emplaced under the elevated sedimentary mass, and this region finally turned to be a mountainous terrain or mountainous region. So this is the whole story of geosyncline concept of tectonic process, and which ultimately led to the development or formation of a mountain. This is the geosyncline concept of mountain formation.